Python is what is called an object-oriented programming language. In this video, I will give a simple introduction to what object-oriented programming is by presenting a short history of the development of programming languages. This history won't be 100% accurate, but it is in the right spirit. That said, early in the days of computers, people devised languages by which they could tell the computer what to do. The first languages were directly related to the computer's hardware. But soon, computer scientists developed more sophisticated languages. 4 such languages dominated the early days. 3 of these, ALGOL, Fortran, and COBOL, were what is called procedural programming languages. That means that the design of programs in those languages is centered on procedures, chunks of code that ask the computer to do some task. We've been calling such chunks functions. In this context, procedure and function are 2 words for the same thing. Program designers used flowcharts to describe their procedurally oriented programs. Each box in the flowchart could be thought of as a procedure. For example, in the flowchart shown here, the box circled here could be thought of as a procedure that buys milk, using up dollars to do so. Diamond shapes are used for decision points, and arrows to another step in the flowchart can depict loops. This flowchart is for too simple a task for its boxes to be real procedures. But imagine a bigger program, like this one for eating cereal. Again, we use a flowchart where here the boxes are big enough to be real procedures. For example, the buy milk procedure would be implemented by using a flowchart that we just saw. The point is that the driving force in designing a program this way is procedures. The software developer breaks the problem into a sequence of subproblems, with each subproblem given a procedure to solve it. Then the software developer breaks each of these subproblems into sub-subproblems, with each sub-subproblem given a procedure to solve it, and so forth until the problem is reduced to a manageable size. This process of repeatedly breaking the problem into subproblems is called procedural decomposition. But back to those early days. 3 of those early languages that dominated, Fortran, ALGOL, and COBOL, were very definitely based on procedural programming. The 4th early language that dominated, Lisp, was also a procedurally oriented language. But it had elements that suggested other ways to design programs too. And so as we moved into the 60s and 70s, other languages, some based on other paradigms, were developed. In the 1960s, the procedural paradigm continued, with BASIC bringing procedural programming to the masses. In the early 70s, the language called C appeared. It has had a strong influence on programming languages ever since and remains one of the most commonly used programming languages today. But the 1960s and early 70s also brought another paradigm, the object-oriented paradigm, in the form of the languages Simula and the hugely influential language called Smalltalk. As Wikipedia comments, Smalltalk was created as the language to underpin the new world of computing, exemplified by human-computer symbiosis. It was designed and created in part for educational use, more so for constructionist learning. It was designed at the Learning Research Group of Xerox PARC by Alan Kay, Dan Inglis, Adele Goldberg, Ted Kaler, Scott Wallace, and others. As programming languages have continued to develop in the last 45 years since Smalltalk, the dominant paradigm, since C++ was introduced in 1979, has been the object-oriented paradigm. Almost all of the important and widely used languages since then have been object-oriented. This includes the language we use in this course, Python, developed about 25 years ago. So what is this object-oriented paradigm? You'll recall that the procedural paradigm is focused on breaking problems into subproblems, with each subproblem having a procedure to solve it. As such, it focuses on verbs, do this, do that, then do that, along with branching and looping. Object-oriented programming focuses on nouns. For example, consider a simulation of a city, part of which simulates the vehicles in the city. One could develop what is called classes for the different kinds of vehicles, including a car class to describe what cars know and can do. A car might ask its axles to spin, and each axle might ask its wheels to to roll. Instead of breaking the problem into subproblems guided by verbs, we develop a solution for our system by focusing on nouns and the relationships between them, what objects are special types of other objects, and what one object can ask another object to do. Today's software engineer designs programs using both the object-oriented and the procedural paradigms. There is a place for each. The key difference is that when she is doing procedural design, she focuses on verbs and thinks in terms of flowcharts. When she is doing object-oriented design, she focuses on nouns and uses UML class diagrams, like the one shown here, to develop her design. Okay, let's summarize. In the early days of programming, software engineers used the procedural paradigm, focusing on verbs to break the problem into subproblems, and those subproblems into subproblems, and so forth, where each subproblem received a procedure or function that solves that subproblem. But somewhere around 1990, software engineers realized that for problems that required big programs, it is also useful to think in terms of nouns and their relationships, doing what is called object-oriented design. So object-oriented languages and notations were developed to support object-oriented design. Python supports both a procedural notation and an object-oriented notation. You have already seen the procedural notation, as in the print example shown here. The next pair of videos will show you the object-oriented notation, as in the example shown here, where a letter of the hello string is replaced to make hello become jello. But to appreciate why we have both notations in Python, you must realize that it is all about design. In some parts of the design process, it is more useful to do object-oriented design. In others, it is more useful to do procedural design. So our programming language supports both ways of thinking. Now, you will not design any big programs until much later in this course, so you won't fully appreciate why object-oriented programming is valuable until later. But even from the beginning, as you learn the notation for object-oriented programming, you can see the fundamental difference between the procedural and object-oriented notations. The former focuses on verbs, the latter on nouns. That's the takeaway from this video. Both procedural design and object-oriented design have their place, with the former focusing on verbs and the latter on nouns.